So our Algebra Refresher is a worksheet that covers a few algebra topics that you may or may not remember from Algebra 1. So if you just have one quick question and you're wondering what you're supposed to do on a section, this slide right here kind of has some helpful information. So go ahead and pause the video and read that over, and if that answers your question, let me show you the bottom here in a minute too. If that answers your question and you know how to complete the rest of the worksheet, then go ahead and do it yourself. Otherwise, I'm going to go ahead and record us going through all of these problems and skip ahead to the ones that you are having struggles with. Starting with, how do we solve equations? So remember, equations are like balances, scales, and whatever you do to one side of the equation, you have to also do to the other. So what I like to do is put a line down the middle of my equation so I know what side I'm working on. And on each side of the equation, you want to combine any like terms. So I notice right here, on the right side of the equation, 6a minus 7a is really negative 1a. So I'm going to write that as that, so I can combine my like terms. And then your job is to solve for a, so our next step is to divide by a negative 1 on both sides. So the negative 1 here will cancel, and negative 5 divided by negative 1 is 5. So please do show work. I don't know you guys all that well, so I want to see all your work written down as well as the right answer. So same thing here on the left side. This time we have some like terms we're going to combine. I have a 5x combined with another 5x, so that's really 10x minus 6 equals negative 6. And then I'm going to isolate the x, so anything that doesn't have a variable I'm going to move to the right side. So let's go ahead and add this 6 over to the right side. And we end up with 10x equals 0. Now don't panic, 0 is a number. Your next algebraic step would be to divide both sides by 10. And 0 divided by 10 is still going to give you an answer of 0. All right, moving along to a little more complicated equation. We have some distribution here in this next problem. So the 5k we're going to stay as it is for now, but we are going to distribute that 4. So working on the left side, trying to clean that up, we have a 5k still there, but now we have a plus 32 plus 32k. And then it still equals 143. So on the left side, I need to collect my like terms. 32k and 5k added together is really 37k. This plus 32 is just going to stay there for now. And now we're going to move it. So isolating all the k's, which means this 32 is going to move to the right side. So we're going to subtract 32. And we are left with, let's see, 37k equals, oh boy, 111. And then dividing both sides by 37. I'm guessing that is 3. But I'm going to confer my answer key. And it is. K equals 3. All right. Next problem, same distribution property that we saw in the previous one is going to have to be utilized again. So this time we're going to distribute a negative 8. So watch their negative sign. 432 stays over here. But now I have a negative 16. And then negative 8 times negative 7 is a positive 56p. So there's no like terms to collect on either side, so we're going to start moving things away from the p. So I'm going to add this 16 over here. Oh boy. All right, 448 equals 56p. Of course, you guys would be using a calculator on this step, so do not panic. We're going to be dividing both sides by 56. And looks like we get p equals 8. If you wrote 8 equals p, that means the exact same thing, so don't panic. All right, moving along. Oh my goodness. All right, these equations are messy. Both sides have some distribution and some simplification before we get going. So I'm going to distribute the 3 to the parenthesis set, and then here, be careful, you're only distributing the 2 to that parenthesis set. So this becomes negative 3n minus 18, and then this is still, that's not being distributed here, so it's just a plus 4. This negative 7n, nothing happened, but now we have a plus 2n, and then a plus 2. So on the left side, looks to me like we have some combining right there, and on the right side we have some combining right there. So new equation is still negative 3n, but now it's a negative 14 or a minus 14 equals, let's see, that's a negative 5n plus 2. So it's your choice where you bring the n's as far as which side. I'm going to bring the n's to the left. So I'm going to go ahead and add this 5n over here, which means if I brought the n's to the left, the constant is going to have to go to the right. Alright, so new equation is 2n equals 17. And dividing both sides by 2. Oops, that's not 17, Abruzzo. Back up. That's 16. Alright, it's 2 plus 14 is 16. Alright, so now when I divide that by 2, I get n equals 8. Lovely. Most definitely, please show work on that question. There was a lot of steps, and every step is a source of error, so we have to be careful. Alright, similar here, we have double distribution, we have combining of like terms, so let's get going here. This new side becomes a 12x plus 12. X equals negative 6 distributed here. Let's see, that becomes a positive 12x minus 24. And then this negative 4x is still subtract 4x. Alright. No like terms on the left, but on the right side you have a 12x and then a minus 4x, so that becomes an 8x, still minus 24. And now we're going to choose to move the variables to one side. I'm going to go to the left with my variable, so I'm going to subtract 8x. Now at the same time, if you don't mind, I'm going to subtract the 12. This is one of those cool Algebra 2 tricks where you don't have to show every single step on its own line. You can kind of combine steps together. So, yay for Algebra 2. Alright, we end up with the 4x, these are gone, equals negative 36. And then dividing both sides by 4, you get x equals negative 9. Hope your brain is woken up now. This next section, the directions really confuse kids, but the actual mathematical act is not too bad. This is called substitution. So I give you a function. It's what's called function notation. So f of n equals 3n plus 2. So this right here, this is the recipe for the function. This is just the name of the function. So when they say find f of negative 6, that means you're going to substitute x, or n in this case, excuse me, n for negative 6, or negative 6 for n. So you go to the body of the function, which is 3 times n plus 2, and then instead of writing n, you plug in negative 6. So 3 times negative 6 is negative 18, and then when you add 2 to that, you get negative 16. So the answer to this question is just negative 16. You don't have to do anything weird with like n equals, because that's not quite what it is. If you want to get super fancy, what you can write is f of negative 6 equals negative 16. That is the absolute fanciest answer I will accept, but you can just say the answer is negative 16 and box it in. So here for number 8, here's the function, 4n plus 1, and we're supposed to be plugging in a negative 3 for the n. So 4 times negative 3, and then plus 1. So let's see, that's negative 12 plus 1. So adding those up, and I get negative 11. Alright, here the function is 3x plus 2, and they want me to evaluate the function at 6. So 3, instead of x plus 2, we're going to write 3 times 6 plus 2. So 3 times 6 is 18, plus 2 is 20. And then finally here, our function is n squared plus 2. Now be careful on this one. You're plugging in a negative 8, but the function where it says n squared, it means you take whatever n is and you square it. So there's no parentheses in the function. They're implied is what we call that. So if I plug in a negative 8 and then I square it, meaning negative 8 times another negative 8, that is a positive 64 plus 2, which is how we get the answer of 66. Now, if you just typed it in the calculator without parentheses, you're going to get the wrong answer, so be careful of the implied parentheses. Simplifying. This is just combining our like terms. So you don't have to do this, but I like to go in what's called standard form order, where I choose the term that has the largest exponent, and that's going to be my leading term. So for this problem, the cubic term, the n to the third power, is my leading term. So I have 8 n to the thirds minus 8 n to the thirds. Those actually end up canceling each other out. So goodbye. Next would be n squared, the quadratic term. So negative 7n plus 1n squared, negative 7n squared plus 1n squared. Negative 7 plus 1 is a negative 6n squared. So we're not doing opposites, we're just kind of smushing these together. And then I have the linear term, which is just n to the first power. So 6n minus 5n would be a plus 1n. You can just say plus n if you put a 1 in front. That's totally fine. And I think we got them all. So if you wrote your answer in the other order, if you said n minus 6n squared, that is totally fine. These are equivalent answers. This one is just in what we call standard form. Alright, same idea here. I look through the largest exponent, the largest term would be the fourth powers. So I'm going to collect those first. So I have negative 3x to the fourth plus x to the fourth. So that's negative 2x to the fourth. And then I don't see any thirds, so let's go seconds. So negative 2x to the second plus 2x to the second. These cancel. And then there's no linear term, but I do see a constant. Plus 2 and a minus 6. Combining those gives me a negative 4. Again, order is not so important here because it didn't specify what answer order they wanted. So if you reversed it, that's totally fine. Just make sure the signs are appropriate. This is the same set of instructions, but the problem looks a little different because we are subtracting all these terms. Now, my brain cannot handle subtracting multiple things at multiple times. So what I'm going to do is I'm going to distribute the subtraction to this polynomial, and I'm going to rewrite it without the parentheses because I just don't like them. 3v plus 3 minus 5v to the fourth. That is not going to change. But this polynomial becomes a negative 5v to the third, and then negative would be a plus 2, and then negative would be a plus 6v to the fourth. So, combining all of our like terms just like we did in the previous problem, I would take the v to the fourths first, and when I add those together, I get 1v to the fourth. And then, let's see, there's a v to the third right here, and that's the only term with v to the third. And then, let's see here, I've got a v to the first, so plus 3v to the first. And that's it. And then there's a couple constants. So we have plus 3 and a plus 2, which is a plus 5 at the very end. That's the best answer in my opinion. But again, if you have another order, that is okay. So same thing here on 14. We're going to distribute the subtraction to everybody, and then we can lose the parentheses. So 2p to the fourth minus 8p to the third plus 8p does not change. But this becomes negative 2p plus 5p to the third minus 3p to the fourth. So now we're going to go back and collect all our like terms, starting with our lead term, which is going to be our p to the fourth. So 2p to the fourth minus 3p to the fourth is negative 1p to the fourth. Then p to the thirds would be next. Negative 8p to the third plus 5p to the third is negative 3p to the third. Let's see, there's no p to the seconds, but right here we have some p to the first powers, so that is plus 6p, and that is all the terms. Rockin'. Moving along. Find the product. Okay, product is a fancy word for multiply. And then in algebra we learned that this action right here is actually called distribution, but what is distribution other than just multiplying? So 5 times 7k is 35k, and then 5 times negative 4 is negative 20 or minus 20. And those are not like terms, so that's going to be your final answer. So the directions here could have said just distribute, and you guys would know what to do. So same thing here, we're distributing or multiplying into 3. So 3 times 6a is 18a. 3 times 4, this would be a minus 12. Again, nothing more you can do there because they are not like terms. This is still the same set of instructions because it's actually the same kind of problem, except this time you're taking a binomial and multiplying it by a binomial. So, we're going to do this one term at a time, starting with this 2x. I'm going to distribute it or multiply it into each term in the other number. So that is 2x times 2x, which is 4x squared. And then 2x times negative 1 is negative 2x. You might remember this as being called FOIL when you were a small child. That's not actually the name. That's a cute little mnemonic device. Negative 2 times 2x is negative 4x. And then negative 2 times negative 1 is a positive 2. So this would not be an acceptable final answer because you do have some like terms here in the middle. So my final answer would be 4x squared minus 6x and then plus 2. There's a beautiful answer right there. All right, something similar happening here on the next step. 8x is going to be distributed to both numbers in the second binomial. So 8x times 5x is a 40x squared. And then 8x times negative 4 is a negative 32x. Negative 7x, negative 7 times 5x is negative 35x. Negative 7 times negative 4 is a plus 28. Again, not an okay answer for us because you do have some like terms right here we need to combine. So great final answer would be 40x squared. This is a, oh boy, negative 67x and a plus 28. Again, remember, I'm going to let you use a calculator, so do not panic. Oh, graphing. It's so amazing how much we forgot about graphing. This is what we keep finding in Algebra 2 is it's been a while since you've had to graph a line. So when these lines are in what we call slope-intercept form, or quick graphing form, the reason we like this form is very easy to graph. So this number, the coefficient to the x, is our slope. And then for some reason we've decided to call slope m in math. But remember, slope is the rise over the run, or the rate of change. So rise meaning either moving upwards or downwards, and then run meaning left or right. The other number in this form, this plus b part over here, this is called the y-intercept. And then I like to call that the starting point. The reason the quick graphing form works so nicely is that if you can identify the starting point, that gives you a point to plot on the axes, and then from there you can go ahead and graph with the slope. So we're going to start at the y-intercept, which is at negative 1. So on the y-axis, which is this vertical axis, you're going to plot a point at negative 1. That is the start. And then your slope is positive 3 over 4. So positive 3 means to rise 3 in the positive direction, so go up 3. And then positive 4 means to run to the right 4 units. So from this starting point, we're going to go up 1, 2, 3, and then right 1, 2, 3, 4. Now technically, you could have moved down 1, 2, 3, and left 1, 2, 3, 4, and it still would give you the same line because if you had negative over negative for a slope, this still comes out to a positive slope because of the two negatives rule. Well, I'm graphing on a tablet. Oh. So I kind of missed my point. I was supposed to cross. But the important thing is that your lines are relatively straight, and then don't forget they have arrows on both sides, okay? So here, negative x plus nothing. I notice there's a plus nothing there. That is important, because if it says plus nothing, you start at 0. So your starting point is actually going to be the origin this time. Your slope is kind of tricky to think about because it just says negative in front of the x. So remember, negative is the number negative 1. But since slope has to be a fraction, I'm going to write it as negative 1 over 1. Now notice, negative 1 over 1 and 1 over negative 1, they are the same thing. So you have to choose which one you'd like to graph first. They can't both be negative. So I'm going to graph negative 1 over 1, which means I'm going to move down 1 unit and then right 1 unit. What I like to do after I graph, so down 1, right 1, is I like to look at my line and decide if I've gone in the correct direction. Because sometimes I get a little dyslexic, which you'll find out I am very dyslexic, and I end up going 2 negative directions, and then I end up with a positive line. But I can tell that this is a downward slope line, and I was supposed to graph with a negative slope, so I feel like I've done that correctly. All right, another quick graphing line, so we're going to start at the y-intercept of negative 2, so on the y-axis, move down to negative 2 and draw a point. Your slope, however, is negative 3, but remember slope has to be a fraction. So that's like negative 3 over 1, positive 1. So I'm going to move down 3 units and right 1 unit. So down 1, 2, 3, and then right 1 unit. Could also move up 3 units if I went left 1 unit. 1, 2, 3, left 1. Creates the same line. Now, if only I could graph a line. Okay. Make sure you draw your line in with arrows on the end. All right, 22 is 5/2 x minus 5, so we're going to start at -5 on the y-axis. And then from there, your slope is +5 over 2. So I'm going to move +5 over +2, which means up 5 and right 2. 1, 2, 3, 4, 5, 1, 2. I wouldn't be able to move down and left because I'm going to run out of graphing space, so I'm just going to have to work with 2 points. Technically, you only... Oh, man. Technically, you only have to graph 2 points, and hopefully your line actually goes through those 2 points. All right, solving by taking the square root of both sides. Not too bad. It's an equation, so we know we want to isolate the variable. I'm going to start by subtracting 3 to move it away from the variable. And I'm not ready to square root quite yet because I still have a coefficient in front of the n. So I'm going to divide by 5 on both sides. Oh boy, I always forget what that one is. Must be 36, huh? So this says n squared equals 36. Well, now mathematically, to undo a squared, I do what's called a square root. But one of the rules about math that everyone forgets, the answer is not just +6, the answer is also -6. So you can either say plus or minus 6, or you can say n equals 6 and n equals -6. They mean the exact same thing. I don't really care how you write your answer, so either this or you can say this separate. Alright, same idea here, guys. We got to subtract the 9 so we can isolate the b. So I have 2b squared equals, oh gosh, I should be able to do that, right? What is that, 8? Alright, divide both sides by 2. Can you tell I'm still on summer vacation? Alright, b squared equals 4. And then remember, we're square rooting both sides, so mathematically the answer is not just a +2, the answer is also -2. So you can either write plus and minus 2, or you can go ahead and separate them and say b equals 2, b equals -2. Both answers would work, and actually I need both answers. So, that's your little tour of algebra. I know it's been a while. Hopefully that didn't stress you out too much. We're going to learn our first lesson tomorrow. It's going to feel like review, and that's okay. We're just going to go a little further than you did in Algebra 1. All right. Thanks for watching the video.